So meanwhile, the K maps here also I will explain. Okay, no need to bother about it. These combinational circuits are also verify by using the K maps. Okay, so whatever the Boolean expressions we are getting, that will be obtained by using K maps. Okay, here what is meant by combinational circuits? Combinational circuits means we are giving the input and immediately we are getting the output without any delay. And then combinational circuits doesn't have any clock signals, all these things. It is operated by using enable signal. I told you that enable signal means it is a switching on purpose, only we are using that. Okay, so switch on the device, that is the, see, if the enable pin is in off mode, okay, you will be getting no output at your side. Okay, so that is the problem. And then uh, see, here we have different type of combinational circuits are there. So adders are there in that. So different adders like full adder, half adder, okay, and then subtract.
So,
Yeah.
one more thing, like for like enable signals, for example, select equal to 1, select equal to 0, can this be called as an enable signal?
That will be also called as an enable signals, but sometimes we have, suppose this is a decoder. Okay, so some 2 by 4 decoder is there. Okay, that means two inputs I am giving. Okay, so those two inputs are AB, and the enable signal means extra pin is there, and then I am getting the three outputs. Okay, how it will be acting like the enable pin means, suppose the enable pin will be off, that means 0, and then if you are providing any type of inputs, and then I am getting like outputs like y0, y1, y2, y3. Okay, three outputs I am getting here, y0, y1, y2, y3. So here also I am not getting any output, all the output should be 0 only. Okay, so during enable pin is 0, if you give any other input, okay, that means different combination of inputs you are providing, but your output should be 0 only. Okay, that is the enable pin operation. Okay, so the select means in multiplexer, select signal is used as a selecting the input. Okay, who is getting at the output side, I am selecting. Okay, user only selecting. Okay, because you are seeing the television, you are the selector, right? Which channel you want to see, right? So same thing here also, select pin is there. Okay, so but the multiplexers having select pins, and encoder, decoder, all these things are having enable pins. Okay, I think you got to know the difference between the enable pin and select pin, right?
Yes, sir.
Fine. So, what is meant by combinational circuits? Well, logic circuits in the digital systems is a, say, whatever the hardware you are designing, that is the combination of either combinational or sequential, right? Whatever the logic circuits we are designing in our digital system, like suppose this is my AND gate or gate I am utilizing. So this should be connected to one sequential circuit, and again this output is connected to combinational circuits. Okay, so this is the another combinational circuit I am taking that, and then this output is again connected to another sequential circuit. Okay, so any digital circuit is the combination of sequential circuit. Okay, so combinational circuit, sequential circuit, combinational, sequential. In this format, we will design our hardware. Okay, so that is the basic thing. Then combinational circuits always consist of logic gates only. Okay, so because the combinational circuits is the output is depends upon the present input only, and there is no past outputs, it is depending on that. Okay, so then whenever you are giving the input, okay, so immediately you are getting the output, right? So suppose any AND gate or OR gate we are designing, then I am getting the output immediately, right? So A, B inputs and C, D inputs we are giving. So if A equal to 0, B equal to 1, C equal to 0, D equal to 0, then you are getting the output immediately without any further delay, right? That is the combinational circuits we are talking about it. Okay, so then combinational circuits are also performs different type of operations by using some Boolean functions. Okay, so then combinational circuits performs like operations that can be logically set by the Boolean functions, right? See how we are setting the Boolean functions here. See, this is my AND gate signal, and then this is my XOR gate signal. Okay, so then I am giving the two inputs A, B. Okay, these two are connected each other, and I am getting some A, B, and then A XOR B output I am getting. How we are saying that these are combinational circuit means based on the Boolean expressions we are saying that. Okay, so these Boolean expressions are producing some outputs. Okay, so based on the Boolean variables only we are performing some operations on the combinational circuits, right? So because there is no Boolean variables, how we can give the inputs to the combinational circuit? How we can give the input to the AND gate or OR gate, NOT gate, okay, or any adder, any subtractor or multiplier? Okay, all these things we need to provide some stimulus, right? That stimulus we are giving through Boolean expressions, okay, or Boolean equations, or Boolean variables. Boolean variables are the inputs, and Boolean expressions are the outputs. Clear? Then sequential circuits are not like that. Sequential circuits are having different elements like this. Okay, some memory elements are there. Okay, those memory elements will be storing the values. Okay, and then output depends upon the present input and previous output also. That is the sequential circuit. The main difference between the combinational circuits and sequential circuits are this is the main difference. Combinational circuits doesn't depends upon any previous values, but sequential circuits are depends upon the output is always depends upon the present and previous values. Okay, so present input and past input also we need to get the output because it is having some memory elements. Clear? Huh. This is my combinational circuit. See, inputs I am giving, I am getting the outputs. Okay, immediately I am getting the outputs. That is my combinational circuit representation. So, in this combinational circuits, only logic gates are available. Any type of logic gates we are connecting, right? Okay, OR gate, AND gate, and then some NOT gate. All these things are connected together, and we will produce some other output like this. Okay, so this all about comes under combinational circuits, and we are giving inputs here, and I am getting the outputs here. Okay, so that is about combinational circuits. How we can convert the sequential circuit means, see, the past output we are giving to input as a combinational circuit, okay, as an input to the combinational circuit. Then we are getting the what it called, we are getting some memory elements. Okay, we are designing some memory elements like flip flops or latches, all these things. See, this is my combinational circuit, some AND gate or gate I am giving. Okay, this is the sequential circuit like some D flip flop I am giving, and I am getting the output. This output again I am giving to as an input of this OR gate. Okay, so then only I am getting the output of my sequential circuit. Okay, so that is the basic difference between the combinational circuits and sequential circuits. Okay, so how we are designing the sequential circuit means,
But actually here it is given both the side combinational logic circuit and here also it is given as combinational logic circuit. Like here we
See,
get memory. Memory.
here also we are giving the combinational circuits because the inputs are providing through some combinational circuits to the sequential circuits. Okay, so the sequential circuits is the combination of memory elements. Like, see, this is the combinational circuit I am giving. So how I am designing the flip flop like this? This is my combinational circuit. Okay, NOR gate is my combinational circuit. This is my combinational circuit. Okay, so here I am taking some SR flip flop type thing, and I am getting like output like Q and Q bar here. Okay, so this output I am connected to input. Okay, the Q is connected to input, then only this Q bar output I am getting, and then Q bar is connected to S input. Okay, so then only I am getting the output. So this is my combinational circuit. Okay, these are the inputs, and then I am giving the feedback here. Okay, so that's why we are getting the sequential circuit. So this is all about called sequential circuit. Okay, no?
Okay.
Huh.
And one more thing, sir.
Huh.
Like any circuit can be designed only through sequential. It is not possible, right? Like if you want to design any like design,
Like,
so
suppose if you want to design register, only flip flops we are using. Okay, so anyway, whatever the flip flops we are designing, some D flip flop, SR flip flop, JK flip flop, ultimately we are combining to, we are designed through a combinational circuits only. But here the difference is the combinational circuits are also having the previous value. Okay, see how we are designing this flip flop by using combinational circuit, but the output is again connected to as an input. Okay, that is the thing, but the pure combinational circuits is not like that. Clear? So pure,
yes, sir.
yeah,
I
pure
got it.
combinational
One more
circuits.
thing, if you want to design any hardware, only
Ha,
combinational plus sequential,
and
both are
sequence.
necessary, or
Yeah.
only combinational. Okay.
No, both are needed. Both are needed.
Okay.
That's why we are learning both the combinational and sequential circuits. Okay. See, n number of inputs I am giving and m number of outputs I am getting in the combinational circuit. See, the combinational circuits consisting of different input variables. Okay, so and then I am getting the outputs, m number of outputs that are different Boolean expressions I am getting. Okay, so that is the combinational circuit diagram, and then here we are giving some binary inputs and I'm getting the binary outputs, some Boolean variable equations I'm getting, right? So n inputs binary variables we are giving, that is the external source, and m variable outputs are producing by the combinational circuit, right? So that is the external destinations. That means whatever the output we are getting, right, some Boolean variables a b plus c d plus, and then da, this type of outputs I am getting, right? So all these are external outputs. What that means, that is my output, or that is my destination to reach while giving the inputs, right? Whatever the inputs I am giving, then to meet this equation, and I want some output from this equation. That is my ultimate aim from the combinational circuits. Okay.
Got it.
So then here n number of inputs you are giving. That means suppose A, B, two inputs I am giving. Then how many combinations we are getting? Two inputs means 2 power 2, four outputs we are, sorry, four combination of inputs I need to give, right? Four combinations I want to give. Suppose A, B, two inputs. How many combinations means 0, 0, 0, 1, 1, 0, 1, 1. Or I am giving the three inputs means how many combinations we are getting? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, triple double 1, 0, triple 1. That means starts from 0, 0, 0 and ends with triple 1. That means starting from 0 and with 7. That means 8 combinations we are getting. That means n number of inputs I am giving, 2 power n number of combinations I will consider. Okay. as an input. Because of that, n number of inputs and 2 power n number of combinations I am taking. Based on that, I will get some what it called combination of inputs. I will take that. Okay, so 2 power n number of combinations, that we will called as a truth table. Okay, so based on the truth table only we will get the different outputs. Okay, we need to write the truth table for that half adder, full adder, half subtractor, full subtractor, all these things. Okay, see, what are the combinational circuits I'm having? See, arithmetic and logical functions, we are doing that. Some arithmetic functions, logical functions, what is that? Adders, subtractors, comparators, okay, and then PLDs, all these things, okay, comparators, all these things are some arithmetic and logical functions we are doing that. See, in adders we are adding two numbers, and subtractors we are subtracting two numbers, and then comparators we are comparing two inputs. And then PLDs we are designing some programmable logic designs by using either AND gate or OR gate. Okay, so we are fixing some gates, either AND gate we are fixing or OR gate we are fixing, or both are programmable. Based on that, PLDs are designing. Okay, and then data transmission, how we are transmitting the data. So by using multiplexers and demultiplexers, encoders and decoders, how we are transmitting the data. See, we are having some encoders. Encoders means whatever the human understandable language is there, that should be converted to machine understandable language. That is the purpose of encoders we are using. And then at the transmitter side we are using these encoders, and then receiver side we are using the decoders. Okay, so decoders, what it is doing means, see here, we are giving what it called. So in during the receiving side, this decoder will convert machine understandable language to human understandable language, right? Suppose I am transmitting the data. Suppose I am transmitting this Verilog PDF or PPT through WhatsApp. Okay, WhatsApp is my channel. Okay, so this is my document. This document will be converted to binary format. Okay, because this binary format only the system will understand. After that, again the WhatsApp I'm seeing on a display. So whatever the document I have shared with you, same document you need to receive. Okay, suppose I have shared the Verilog PPT document, but you will receive like 100111 some 10, this type of data you are received means, then how you can read that Verilog document, right? So that is the reason decoders are placing at the receiver side. It will decode that, and again it converts to the original format, original data format. Okay, and also some code converters like binary, BCD, 7 segment displays, all these things we are having. Okay, see, basic
One more thing. What is the role of encoders? Like exactly in the combinational circuit, what it does?
encoders, it will encode that. Suppose whatever the data we are taking, okay, that will be converted into some binary formats. Okay, so that is the encoder purpose. And then decoder purpose, whatever the binary format you are transmitting at the transmitter side, and then receiver side it will be converted to some text format or document formats, all these things. Okay.
Yes.
Huh. That is the main usage of encoders and decoders in our combinational circuits. Okay.
In combinational circuit, as you explained, like BCDs, like numbers, ALUs, everything was like a basic one, right, to design any combinational.
Hmm. See, if you want to perform arithmetic and logical operations, that ALU is needed because the processor is doing some arithmetic and logical operations. Then we need these adders, subtractors, and multipliers, and then all these things. Okay, so demultipliers, sorry, multipliers, boost multipliers, valence multipliers, and then all these things are used in our processor. Okay, then ALU will be taking care all the arithmetic and logical operations. Previously, we know the logical operations: AND operation, OR operation, NOT operation, XOR operation, exclusive OR operation, NAND, NOR. All these things are primitives. Okay, the Verilog code is always inbuilt gates are there. Okay, anyway, it will produce some output whenever we are giving the input. Clear?
Yes.
Huh. See, this half adder, we are having two inputs, okay, and we are getting the two outputs, that is sum and carry. Okay, when we are getting the carry and when we are getting the sum, see, anyway, if you add two numbers means 0 plus 0 means sum is the output, right? Suppose this is my half adder, x and y are the input, and then s and c are the outputs. S means sum, c means carry. Why I am getting the carry here? Suppose 7 plus 6 I am adding here, then 7 plus 6 means 13. So 3 is my sum and 1 is my carry. Okay, so then 1 is getting here, that means 3 is the sum and carry is the 1. That means 3 is the units place and 1 is the tens place. Okay, so in that way we will add two numbers in our combinational circuits. This half adder trying to add the two inputs here. Okay, 0 plus 0, there is no sum and there is no carry. Okay, so if you add the 0 plus 0 means 0 only we are getting, right? So 0 and 0 only, and then 0 plus 1 means, okay, just give me 2 minutes. Yeah,